All right, so stacks and queues are a basic data structure, and they're the basics of the basics. And if we're gonna do data structures and algorithms, we have to know these backwards and forwards. Thankfully, they're actually fairly straightforward. Yes, there's variations of them you can get into, but in this video, my job is just to give you the basics so that we can move forward. All right, they're going to appear later on when we do other techniques and data structures. So again, they're kind of like building blocks. All right, what is the point of a stack and a queue? The stack and a queue is just a way of dealing with incoming data. All right, so what does that mean? Essentially, when a piece of data comes in, how should we order it relative to other pieces of data? Then how should we deal with it? So stacks are last in, first out. Queues are first in, first out. All right, that is kind of, if you've done accounting, you've probably heard of LIFO and FIFO. Essentially, what it means is, hey, we've got an incoming piece of data. All right, if I want to move on to the next one, what do I do? A stack typically is, you can think of it, well, just like a stack, like this. Like I usually picture like cafeteria trays, all right, or you can picture like a little box you put stuff into. All right, so let's say we have a piece of data coming in. Let's say it's a number. Okay, again, it doesn't have to be a number. It could be a letter. It could be an object. It could be whatever the heck you want it to be. All right, last in first out basically means is, let's say I've got some numbers. I put in 12. All right, and then I put in 13. And then I put in, I don't know, 2. Notice how I'm stacking things on top of one another, right? So the first thing that was put into my stack was 12, but notice how it's at the bottom. So how do stacks work? All right, so I've got my stack. I put in 12, and I put in 13, and then I put in 2. And again, like cafeteria trays, you stack them one on top of the other. With stacks, we can do a couple things. First thing we can do is we can peek. Okay, what does peek mean? Peek means, hey, take a look at the top element in the stack and tell me what it is. Stacks are all about the top element. Everything below it, right, is not going to be immediately visible to us. So picture that, like, we can't really like look at what's in this area. We can only peek and take a look at the topmost element. So if I do peek, I'm going to get 2 because 2 is at the top of the stack. All right, well, Jonathan, I don't want 2 to be at the top of the stack anymore. I don't really, you know what I'm saying? I want to do something different. All right, we can pop from the stack. Okay, we do the pop method. What pop means, I think of like a Pringles can, where you take the top of the potato chip can and you use your thumbs and pop it off. Right, that's kind of the way you can envision this. Right, we're gonna pop off 2, so you can literally think of, okay, we're gonna get rid of 2. Notice how we can't pop off 13 and we can't pop off 12 directly, right? Pop means take the topmost element and take it out the stack. Okay, that's why I said last in, first out. 2 was the last element I put in, but when I want to get rid of an element, it's the first out. All right, so we popped, and now our stack has 13 at the top and 12 at the top. Okay, we only can deal with the topmost element. That's the main idea here. Now, what happens when I want to put something on top of the stack? All right, well, what I can do is I can push. Oops, let me do that in blue, because I did everything else in blue. So let me do that in blue. Yada, yada. All right, push. Okay, that is our next method. Okay, and you can push a certain number. So let's say I want to push 4. Okay, that means that we have 4 over here, and then we push it on top of the stack. Okay, so notice how it goes on top now, and 13 and 12 are still on the bottom. All right, so we can push and we can pop, and stacks are always about the top of the stack. Right, last in, first out. When you're working with stacks, you just kind of have to remember these are like the 3 superpowers it has: peek, pop, and push. And stacks always deal with the topmost element. For example, you can't pop 13 because 13 is down here. If you want to get to 13 or 12, so you want to get to 12, you have to do pop first, and pop will get rid of the topmost number here. And then you have to pop again to get rid of the 13. Then you can get to the 12. Okay, so that's kind of the thing you have to remember. You can't skip. You can't go from the top all the way back to the bottom. You have to remove things from the top until you get to where you want to go. Just like with cafeteria trays. You can't just like take the middle tray magically out the middle. You have to like get rid of the trays on top, like remove them from the top and then get to the tray you want. Okay, that's the kind of way you can think of stacks. All right, now, hopefully that made sense. Okay, peek, pop, and push are the 3 things you can do with a stack. A stack is where you can envision you're putting the data one on top of the other. Last in, first out. Peek lets you look at the topmost element. Pop removes the topmost element, and push adds another element on top of the stack. Those are the three things you need to kind of remember. Let's see how we can do this in Python. Implementing a stack in Python is actually really easy. To make a stack, we're just going to basically use a list. All right, lists basically work how we would want stacks to work. So we can use stack.append A, stack.append B, stack.append C. So you'll know that there is an append method for lists. And let's go ahead and print the stack, and then let's run this. Alright, so as you can see at the very top of the stack is C, which was the last thing that we put in. So last in, first out. So if I were to do stack.pop and then print the stack again, let's kind of see what happens. So I put A, B, and C on the stack, and then we saw what the stack looked like. Then I'm going to pop. Okay, remember pop takes the topmost thing on the stack and gets rid of it. And then we'll see how the stack looks afterwards. Alright, so originally we had A, B, C, and then we popped, and then that got rid of the topmost element. So we got rid of C, and now we just have A and B. And if we do stack.pop again and print out the stack one more time, you'll see that we go all the way down to A. Alright, so you can see that pop just basically takes the quote-unquote top of the stack. I'm just using top just to kind of help you to visualize this, and it gets rid of that element, right? So we can't directly, when we have A, B, and C like this, we can't directly get to A and B. C is at the top, so that's what we're looking for. Now, there is no like peek method per se. You could just, of course, print a stack at, let's say, -1. All right, and so let's go ahead and do that. So I'll get rid of all this pop stuff and just go ahead and do this. All right, and you'll see that it gives you C, which is the last element in the stack. And so remember, in Python, you can use a -1 as the index to get the last element in the list, and that is the last element is the thing that we would peek. All right, so there is no like built-in peek method. You would just do this. So this stack is pretty straightforward, right? The only things you really have to kind of remember are the append method, all right, and then the pop method. So pop means take the last element and get rid of it. You can think of the last element basically as the top of the stack. So this is how you would actually use a stack in Python. Hi, my name is Jonathan Hopp, and if you're enjoying this tutorial, I invite you to visit my website, codingyourcareer.com. I've got courses on Java, JavaScript, TypeScript, and all of the famous frameworks like React and Angular, the kind of things you'll need in order to break into the world of tech and get the knowledge that you need. It's even great for people who are already in tech and want to like level up their skills. So it's codingyourcareer.com. Let's continue with the tutorial. Now, queues are FIFO. They're first in, first out. And the easiest way I have of kind of explaining a queue for you to like visualize it through metaphor is a grocery store. Like go to the grocery store and you're ready to check out. All right, when you're ready to check out and you go to the grocery store, there's a line of people at the checkout counter. All right, how do we deal with those people? Okay, when you first go up to check out, the first person who comes in is the first person to get checked out. Okay, they go in line, they put down their groceries, the lady at the counter starts to, total everything up. Okay, that's how it basically works. When you want to get in line, you always get in the back of the line. You can't skip. I guess technically speaking, you could skip people in the line. I don't think they would be very happy with you. The way the line is supposed to work is that if you want to get in line, you always get to the back of the line. The person who's being served is always in the front of the line, and then we add new people to the back of the line. And we don't do the people in the middle are just the people in the middle. Okay. So I know in real life you can leave the line if you want to, but in our scenario, everyone is there and they want their food, they want to check out. So in order to leave the line, you have to check out, which means that the person who's at the front of the line gets served. If they want to leave, they got to wait till the cashier rings them up, and then they leave the line. So I have a queue here. I marked front and back, and we're going to kind of learn some vocabulary words here. So we're going to enqueue and dequeue. Okay, so Q. Okay, I love this word. I can barely spell it. All right, so how does this work? Okay, NQ means get in line. DQ means get out of line. That's basically the easiest way of thinking about it. NQ means get in line. DQ means get in the back. All right, let's say we have some numbers, right? We're going to NQ 10. Okay, so 10 is at the front of the line. We're going to NQ 35. We're going to NQ 40. See how, like, as I add the numbers in, the new number is at the back of the line? All right, so whenever you NQ something, let's NQ 65. I'm just throwing out random numbers here. They always go at the back of the line. Now, when you DQ a number, let's DQ 10, so we get rid of 10. Okay, when you DQ, it's always going to be the number at the top of the line. Okay, so when you DQ, it's never, you can't like DQ 40. Okay, DQ 65 is not the way it works. You always take the number in front and then you take it out of the queue. And then now 35 is at the head of the queue, right? And then if we wanted to DQ again, it would be 35, that would be the number that goes. And then 40 and 65 would move up. I'm going to just move them up real quick. 40 and 65. And then if we NQ new values like 100 or 2, they get into the back of the line. All right, so that's kind of things. All right, so you might be wondering, like, what's it like? When do we use stacks versus when do we use queues? Because queues are actually, I think queues are actually the easier of the two to understand, especially since I think most people have real world experiences of waiting in line for things. So I think that they're pretty straightforward. All right, but after learning NQing, DQing, how do we know like whether I should use a stack or whether I should use a queue? That's going to take some experience. Anytime, again, where you could model it, you could imagine it's like people waiting in line. Like, so for example, a multiplayer game. People log onto the game and they want to, like, get into a certain room or get into a certain raid group. Well, the people who, it's first come, first serve, right? So any kind of first come, first serve situation, a queue makes sense. A stack would be used for keeping a history. So, for example, web pages. So, like web pages, you go to dailypuppy.com, and then you go to a link where you go to puppymania.com, and then for your third site, you went to puppyworld.com. Well, when you hit the back button, you should go back to the previous page. So you could take the current page and pop it off, and then you would have your previous page. So stacks are really for any kind of thing like history, where you're layering one thing on top of the other. That's why I constantly draw this stuff out, so you can have a way of envisioning this. All right, let's actually write out queues in Python, and then that should give you a good enough basis to work with stacks and queues. All right, we're gonna use a library actually for the queue. So from collections, import DQ. All right, so what is DQ? It is basically a double-ended queue. It is a data structure kind of built into this library, and it is going to be a lot more optimized than using a regular list. So let's learn how to use it. I'm going to make a queue, and it's going to be an instance of DQ, and we're going to actually go ahead and put things in the queue. So queue.append Bob. So Bob gets in line, and then Mary gets in line, and then Joe gets in line. All right, so people getting in line at the grocery store. All right, so they get into line, and then we'll go ahead and print out our queue. Oh, come on, let's get to typing. There we go. All right, so I'm going to do Python queue example. All right, so there we go. Bob, Mary, and Joe. So Bob is at the head of the line. So let's go ahead and I'm going to do that again. I'm going to put one more person in there. Should equal. All right, and then let's see what happens. Okay, so as you can see, Bob is the head of the line, and then whoever comes in gets to the back of the line. All right, so we're going to then DQ people. All right, so this is NQing. All right, this is NQing. Getting in line basically, and then we're going to DQ. which is like to get, like, basically when the person's called by the cashier to go and ring their stuff up. When they're done, they leave the line. So we'll do first out is equal to q.pop_left. Alright, and again, pop left makes sense because this is the left side when I printed it out, so we're going to tell this person, okay, cool, you're done. You can go ahead and go on with your life. Alright, so let's go see what it looks like. Oops, did I miss something? Oh, lowercase l, duh. Okay, coloration should have told me. There we go. Alright, so Bob, Mary, Joe, Shaniqua were in line. Then Bob, finished checking out and got his bags and is leaving the store. And so now Mary's at the head of the line. Okay, so pop left basically took Bob and got him out the queue. So we DQ'd, and that got Bob out. All right, so if you'd like to peek, at the top of the queue, like which person's at the head of the queue, then you can look front is equal to Q at index 0. All right. That's basically it, right? There's nothing special. There's no like special peek method. It's just, I forgot to print the front. So we'll print the front person, who is Mary. All right, it's just essentially the person at index 0. So you'll notice that peek in both the queue example and in the stack example, there wasn't a specific peek method. You just have to look at the element at the correct spot. But for DQ, you also can use DQ for stacks as well. Obviously you use it for queues. Stacks, you can use a regular Python list. That's perfectly fine.